This is my latest apparatus for experimenting with parametric excitation of electrical oscillations. It's a wheel on a brushless motor, and it has some ferrite sleeve tubes, 6 of them in the wheel, so those little ferrite tubes go from one side to the other. Now, after many hours of painstaking work in the machine shop, I have finished the precision engineering of this exquisite demonstration model for parametric excitation of electrical oscillations. This is our variable inductor. So there are two 5.6 millihenry inductors in series, and then our wheel with the ferrites is in between them, so we get a variance of inductance from around 13.4 microhenries to 14.8586. Our model is now set up for demonstration. We have our variable inductor serially connected with a capacitor, so we have an LC circuit. We have a motor driver and power supply. So I am going to turn the motor on, and then I will be adjusting the frequency of the motor with this potentiometer, adjusting the speed of the motor, I should say, and the frequency of oscillation of the system. While I am making that adjustment, I will be focusing on the oscilloscope screen. The oscilloscope is connected across the capacitor in the LC circuit, and we will watch as the frequency increases and we find the resonant frequency of the system, the energy circulating in the LC tank will increase to its maximum value. So we'll start it up and have a look. So now I'll increase it a little bit more, and you can see that we've passed the frequency of resonance. So I'll back it up to that high point, which is around here, and you can see we've got a maximum and minimum voltage of about plus 1.2, 1.3 volts, and the same on the low side. So we'll see what our amplitude is. So amplitude is 2.4 volts. And now I'm going to turn this off. So everything was working well there. I imagine that the amplitude of voltage that we saw on the scope was only limited by 2 factors. So one is the degree to which inductance is varied. So the system would be, there'd be more energy in the LC tank if we were varying this inductance to a greater degree. And the other thing is the system Q. So the Q factor of these coils, if it were higher, then we would see more energy in the tank. But you can see that this system limits itself. I haven't measured the resistance of these coils to do a power calculation, but I can do that, although I can tell that it's not going to be particularly great. Not enough power in the tank at this stage to bother looking at the input power. I don't think that this is really loading the motor, but I could be wrong, and I'd have to do some measurements to check that out. Thank you for watching.